For decades, Toyota built its reputation on quiet strength, the dependable force behind millions of drivers worldwide, never needing to shout to be heard. But something shifted. In a rare, pointed statement, Toyota's CEO stepped into the spotlight with a message few expected. Our new dynamic force engine will destroy the competition. It was more than a challenge. It was a signal that Toyota was no longer content staying in the background. So, what exactly is this engine? And why is Toyota so confident it will leave everyone else behind? Let's uncover the real story behind Toyota's boldest move yet. Toyota is not just improving its engines, it's changing how they work to meet future needs. With its new Dynamic Force Engine series, Toyota is focusing on improving fuel engines. And while many other companies are switching completely to electric vehicles, these engines are not small updates. They are part of a long-term plan connected to Toyota's global design system called TNGA, or Toyota New Global Architecture. This system helps Toyota build cars that are stronger, more efficient, and easier to produce. And while many companies are focusing only on electric cars, Toyota is improving both fuel and electric systems. The CEO of Toyota said that the new Dynamic Force engines are a big part of the company's plan. These engines are designed to use less fuel, create fewer emissions, and still deliver strong performance. They can also work with different types of fuel, such as ethanol or hydrogen. Toyota believes that fuel engines can still improve and play an important role in the future of transportation. Around the world, transportation needs can be, well, pretty different. That's why Toyota focuses on designing engines that fit a variety of environments and lifestyles. By understanding what people need in each region, they can develop solutions that are practical and efficient for everyone. This choice is based on global needs. In many countries, electric cars are not practical because charging stations are limited and electricity is not always reliable. In those places, efficient fuel engines are still the best option. Toyota is building engines that can work in these areas, while also meeting environmental rules and keeping costs low. The new Dynamic Force engines are designed to work with Toyota's TNGA platform. TNGA is a system that allows different cars to share the same parts and design, which helps reduce production time and makes it easier to use the same engine in many types of vehicles. For example, the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes like switching to new types of fuel. When we talk about efficiency and flexibility, it's really about how well a system can adapt to different needs while still delivering great performance. These qualities are especially important in modern engines, where getting the most out of every drop of fuel and being able to handle different driving conditions matter more than ever. The Dynamic Force engines focus on more than just speed or power. They're built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency, meaning the engine can turn more fuel into usable energy rather than losing it as heat. These engines also use a longer piston stroke and a mix of fuel injection methods to improve performance and reduce emissions. The inline-4 is the most common type found in many midsize cars. The V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production, so the same engine can be made in different countries with local parts. This saves time and money while keeping quality high. It also helps Toyota deal with supply issues or changing demand in different regions. Because these engines follow the TNGA system, Toyota can quickly adjust production based on local needs. In today's automotive landscape, staying ahead means not just keeping up, but actually setting the pace. Toyota's Dynamic Force engines give the company a real competitive edge, showing clear results in the real world. By focusing on both performance and efficiency, Toyota is able to deliver vehicles that meet the demands of drivers and regulators alike. This ongoing commitment to innovation has helped Toyota achieve impressive results, not just in the lab, but out on the road, where it truly matters. So, why does this help Toyota compete? Well, the Dynamic Force engines give Toyota an advantage. While other companies are moving away from fuel engines, Toyota is actually improving them to meet both current and future needs. These engines are ready for multiple types of energy, and work really well with hybrid systems. This approach helps Toyota stand out in a rapidly changing market. The dynamic force engines are designed to fit perfectly within the TNGA layout. What this means is that engineers don't have to redesign the car every time they improve the engine. This flexibility helps Toyota stay ahead, especially in markets where clean energy is growing quickly. By building flexible cars that support different powertrains, Toyota can adjust its lineup without big design changes. This is a major advantage in today's auto industry where energy systems are changing fast. Several cars built with TNGA and dynamic force engines are already on the road. Models like the Toyota Corolla, Camry and RAV4 use this setup, and they have seen improvements in both performance and efficiency. Drivers notice better fuel economy, quicker response, and smoother driving. For Toyota, these results show that the TNGA system works as planned. Automotive progress has always been closely tied to advancements in engine design. Over the years, engineers have continuously pushed the boundaries, striving for greater efficiency, power, and sustainability. It's this relentless pursuit of innovation that has driven the evolution of vehicles as we know them today. Every major leap in automotive progress begins with the engine. For Toyota, the dynamic force engine represents the next stage in internal combustion design. These engines are not simply a tweak of the past, they are a complete redesign of how power efficiency and emissions are balanced. Developed from scratch and built to pair with Toyota's TNGA platform, the dynamic force family brings a focus on thermal efficiency, smart air-fuel management, high-speed combustion, and mechanical precision. Toyota's engineers embarked on a mission that the broader automotive engineering community had long considered an exceptionally difficult, if not nearly impossible challenge, significantly increasing the thermal efficiency of a conventional gasoline engine to achieve levels that had historically been the exclusive domain of more complex hybrid systems or highly efficient diesel powertrains. When it comes to pushing the boundaries of what's possible, Toyota's relentless pursuit of thermal efficiency and technological advancements really stands out. By reimagining engine design and integrating cutting-edge innovations, they've managed to set new benchmarks, not just for themselves, but for the entire automotive industry. This commitment to progress, honestly, is what continues to drive the evolution of modern mobility. In the realm of internal combustion engines, thermal efficiency is the critical metric that refers to the percentage of a fuel's inherent chemical energy that is successfully converted into useful mechanical work, as opposed to being lost as waste heat through the exhaust or cooling systems. Traditional well-developed gasoline engines have typically plateaued with thermal efficiency in the modest range of just 30 to 33%, meaning the vast majority of the energy from each drop of fuel was being squandered. The revolutionary dynamic force engines audaciously break past this long-standing thermodynamic barrier, with documented figures now reaching a remarkable 40% in standalone gasoline-only configurations, and climbing even higher to an unprecedented 41% when integrated into hybrid setups, effectively closing the efficiency gap with other powertrain types. This monumental improvement does not stem from a single silver bullet, but from a deeply integrated and synergistic combination of advanced technologies, all working in perfect harmony. Instead of focusing on enhancing just one isolated system, Toyota's holistic approach involved a fundamental re-examination of how every single component and phase of the combustion process could be radically enhanced. This comprehensive optimization represents a fundamental re-engineering of the internal combustion process, where every component and phase has been radically enhanced through synergistic technological advancements. Fuel delivery and air management are honestly at the core of this transformation, ensuring that every drop of fuel and every breath of air is precisely controlled for maximum efficiency and performance. The system begins with the precise high-pressure delivery and microscopic atomization of fuel, where advanced injectors operating at extremely high pressures create an exceptionally fine mist of fuel particles, enabling a more complete and efficient burn that extracts maximum energy from each droplet, while significantly reducing unburned hydrocarbon emissions. This is complemented by the intelligent management of airflows into the cylinder through specially engineered high swirl and tumble ports that create controlled turbulence, ensuring optimal air-fuel mixing throughout the combustion chamber for uniform combustion and minimize localized hotspots. Within the combustion chamber, careful engineering further boosts thermal efficiency. By optimizing the shape and materials, heat losses are minimized, and combustion is kept consistent, so more of the fuel's energy is actually converted into useful work, rather than being lost as waste heat. This, in turn, helps improve overall engine performance and reduces emissions, making the process both powerful and efficient. The innovative reshaping of the combustion chamber itself represents another breakthrough, featuring a carefully calibrated geometry that supports ultra-lean burn capabilities and unprecedented high compression ratios, allowing the engine to extract more mechanical work from the same amount of fuel while maintaining stable combustion characteristics. This chamber design works in concert with the meticulous management of heat during ignition, incorporating advanced thermal barrier coatings, optimized cooling jacket designs, and strategic material selection to minimize parasitic heat losses to the cooling system and maximize the energy converted to useful work. Now, all of these improvements really come together at the systems level, where each element is engineered to complement and enhance the others, resulting in a kind of synergy that just wouldn't be possible with isolated upgrades alone. The concerted and simultaneous improvement across all these interconnected areas, fuel delivery, air management, combustion chamber design, and thermal efficiency, creates a virtuous cycle of enhanced performance where each enhancement amplifies the benefits of the others, representing the pinnacle of systems-level engineering that required reevaluating and perfecting every aspect of the combustion process from first principles, rather than incremental improvements to existing designs.